This is the JB Scorpion as it has come to us. So, mountain of work I'm gonna get done on this van. The current control panel, it's very basic, and it sort of looks like there's just been stuff added along the way. Why they are not aligned, I have no idea, because I'm pretty sure they were installed from factory. Low voltage disconnect, isolation, circuit breaker, fuse panel. Down here, fridge, compressor fridge. Then under the bed, from what I've been told, what I believe, this is the factory system. So it's an Enerdrive pre-wired board. I think they still do these ones. So it's 2000 watt inverter, 40 amp DC charger, 40 amp AC charger. But you've only got 200 amp hours of lithium. I'll check the app. So that's the Enerdrive battery. It's done 98 cycles. Like I said, yeah, it's a 200 amp hour battery. Sat King and whatnot on the roof, which we will be deleting. Wine guard, that will be going. And then the roof, current roof layout of the van. So the 1, 2, 3 panels factory, the 2 panels at the front were added by the customer. He added a couple of years ago, or about 12 months ago. But as you can see, they're on a little bit of a slant, and they're all just running through the one solar controller setup at the moment. And I haven't done the math, but I would be suspecting with those 2 extras, they'd be maxing out that 40 amp Enerdrive DC charger that's looking after the solar. So when they're driving, the actual alternating charge is doing bugger all. Sat King, see you later. This one here, see you later. I'm gonna go through the solar on the roof now, pull up the panels, get the specs of them, and then what panels we've got here and what panels we've got access to. I'll talk to the customer and give my best advice on what to do. Probably give them 2 options, if we can mix and match, or just start fresh and maximize it. Or even if we keep the 2 ones at the front, as they're only 12 months old. Just depends on brand. Give them a bit of a test once we pull them down. It's a nice day here, so we'll be able to test them on with the Victron MPP10, just make sure that they're pulling out what they're rated to be putting out. A couple of little extra things. Blackjack is going to need power, and then they've got an Anderson plug on the other side of the van already, which is an input output, but because we're going to do an Anderson plug blackjack power at the front, this Anderson plug that is down here is going to turn into a solar Anderson plug, and it will go through the screen, so it'll read in the solar section of the Victron screen. I think that's probably it for now. Try and do a bit of a update throughout. Okay, quick update. As you can see, we've managed to salvage some gear, bits and pieces from the roof and from inside. Just working through the layout of everything. Got a lot of solar controllers, which we'll explain in due course why we're doing them like that. Just getting all our trunking and layout sorted. 5KVA MultiPlus going there. We've got the fridge out because we're rerunning some cables, and then today we're going to run more new cables on the roof. So 100 watt solar panel. That came from this spot here up the front, which looks like at this stage we're going to keep these and run these on a separate solar controller. The Sat King was up the back. The wine guard is now gone. I'm literally just waiting on confirmation from the customer with regards to the roof and what we are planning to do. So as soon as they give us the okay, those panels on the roof come up. Basically give the whole roof a clean up with the wiring, give the whole roof a bath, so that when we adhesively mount down all our new panels, they're gonna have a good seal and stick well. And then one last part, now that we know that we are going to do the tank levels and whatnot. So this screen is going to be, or screen area, it's going to be reworked. We're going to cut a rectangle out, put a new panel up, move over what needs to, get rid of like battery monitor, the inverter switch, and then the tank sender screens that were down here. That's all going to go. And then you'll have power point, switch panel, the 240 switches for hot water, water pump, drinking water, aircon, and electric hot water. And then that'll all go on a new panel that we'll put up there, as well with the servo screen. We were going to try and get the servo screen on this panel here, but as you can see, not much access. We tried to get access through the back of this where the Sat King was to in here, but no dice. And because the Victron screen runs with a HDMI cable, you can't just get it through a 10mm hole. You've got to be getting it through like a 25mm hole, because unfortunately Victron servo screen runs with HDMI, which I'm sure one day they're going to change, but it's just to punish at the moment. But anyway, that was the update. And now it looks like this. So I might have missed a little bit in between of the process, but this is the finished product. Now fully complete, minus the lid going on the box. You'll obviously see there's a lot of blue stuff on the rear wall of it. Again, that would have been, like I spoke about earlier, the extra solar system on the roof and the solar Anderson plug-in input. So I'm going to drop a little video in, which will be like a screen recording of a video I took the other day of us running the aircon off the inverter, and they're basically running it for free directly off the solar, which is fantastic. Now, system-wise, you've got two Element3 Core batteries, 350 amp hours, so 700 amp hours each. That lid is going to go on there. It's got a seal on the bottom side of it to screw down, and then all the terminal cables have been sealed, and the ventilation port has also been sealed. And then we've got our AS3001 label kit. These are a Trafalite cut label that we make and sell, and yeah, the AS3001 label kit. There's a couple other stuff there with some solar that's just got to go on once I put the lid on, and then we are good to go. Now obviously 5KVA inverter, it's a 12 volt one. Yes, we're going to go through and test it and do all the temperature testing, just so all the YouTube Nazis don't get in the comments and say you shouldn't be doing a 5KVA inverter in a 12 volt system, because I'm not really interested in those comments, to be honest. Because if you couldn't do it, then Victron wouldn't make it. Solar system, you got a 20 amp solar controller, which is our fourth solar circuit. That's doing the two 100 watt panels on the roof. 50 amp, which is doing two 250s, another 50, which is doing two 250s, and then a 130, which is doing two 80s, plus the blanket that they're going to put on, which will be like a 300 watt blanket. So the whole solar system is all done through the Victron stuff. There's a couple other Anderson plugs that we added, just like the black jack at the front. And then there was one that was already on the side of the van, which we've just kept. 50 amp Orion XS, so DC charger. Obviously you've got your solar circuit breakers and stuff there as well. Smart signal converter from Steve at RV Electronics. Very good bit of kit that he's designed to make the tank senders compatible with the servo unit. So you've obviously got your servo, some fuse panels, and then more fusing down here, and then the rest of it's pretty much all trunking. Now we've got one of these bad boys, which is our Element3 Starlink Mini DC converter, and we've actually hardwired it. So again, I'll drop a photo in of what we did there. So on the outside of the van, they had an original cigarette socket. This has got nothing to do with what we've done, but we have installed a female output. So all the customer is going to do here is buy the Starlink Mini kit. They're going to have the dish, and then they'll have the 15-meter cable that comes with the dish. They plug it into there, and there's no switch on that circuit. So them plugging it in is switching it essentially, and then that's a 15 or 20 meter lead that comes with the Starlink Mini, and that's going to be at 30 volts from the converter. So you've just got a 12 volt input to the converter through the fuse panel, and then we've hardwired the output to that unit. So yeah, 30 volts, which is perfect for the Mini. You've obviously got your AC circuit breakers and whatnot there, and then you've got your 12 volts. So you can see we don't have links in the battery box. The links is actually done down the bottom at the circuit breakers with a bus bar. So that's to obviously share the load, and then that third circuit breaker is to go to the rest of our charges and inputs, outputs. So 5 kVA inverter, you've got 2 times 70 mils. Yes, people are going to say, oh, I should have done 24 volt, 5 kVA, less cables in between the battery. It's like half a meter, mate. It's okay, relax. It's not going to make the world's biggest difference, a couple extra bucks in cable here and there, okay? Because then with the 24 volt system, you're buying the converter to step it down to 12 volt anyway, because all these lights and whatnot are 12 volt only, they're not dual input. And then we gave the control panel some love as well. So just kept the switches that were here, power point and the switch panel, and then obviously added in our servo. Got our 4 tanks, front fresh, drinking water, rear fresh, and then grey water. And then, yeah, everything, all our devices are all in here. You've got your 4 solar controllers, DC charger, Scorpion lithium, that's the shunt, obviously, MultiPlus. Electrical cupboard. Now, what I'm going to show you here, I'm going to need to get this bad boy. So, again, people are going to say, oh, under the bed, a lot of heat. What we've done, 2 fans here and then a vent over here, but these are automatic fans. They are controlled by the electrical cabinet temperature sensor. So what I'm going to do, it's at 22 degrees at the moment. I'm going to get this heat gun and I'm going to point it in the direction where the temp sensor is, and just get it to heat up a little bit. And now, because I've just heated it up, the temperature sensor, these fans are on. Now, we've got a little smoke machine. I'm going to show you that, you know, it's actually doing something. So if we put stuff here, and you can see it getting thrown out the other side. So it's doing exactly what it's meant to be doing. And then with the vent that we've drilled down there, it just allows for the air to pull. And then there's actually also another vent over this side of the bed. So super nifty way of setting up some fans to have them just temperature controlled, because now you'll see that that temperature is obviously through the roof because I just hit it with the heat gun. But that's going to cool down, and then once the temperature hits 23 degrees, I'm pretty sure I set it to, those fans will just turn off automatically. And like draw wise, you won't even notice it on the wattage. It might give you an extra 5 or 6 watts of draw. So they use bug roll power just to keep the airflow from here, coming this way and that way, and then pushing it back out on the top side of the inverter. The inverter's also got a fan built into it as well. All right, let's get into some testing and try and get this inverter to show its true colors. Got a couple of 240 devices out now. All right, I've got just a cup of water in there. I've got the aircon on, 30 degrees heating. It's pulling 900 watts. All right, let's turn on the kettle. That's taking us up to 2800 watts, 3400 watts off the battery just with our conversion losses. If I turn the toaster on as well, now we're getting up to 3700 and 4500 off the inverter. And then let's turn on the microwave as well. And now we're getting our 5000 watts, 6400 watts off the battery system, and 500 amps. All right, now let's see what these temperatures are doing. 26 degrees at the moment. I'm gonna let that run for a bit. Just Still got these two going. Turn that back on for a minute. Get this system really cranking. One other thing I'll do with the batteries while we're doing this is I'll check the JK BMS app. 250 off one battery, 250 off the other batteries. The batteries are wired perfectly. One very important thing that you need to make note in a system like this is your actives and your neutrals, the same length, exact same length across both batteries. That's why there is a little bit of slack in the back there, because we wanted to make sure that they were all going to be the exact same lengths. Down at the bus bar, we're at 31.2. Battery case temperature is 26 as well. So you got kettle, 2-burner toaster, you've got aircon on, and you're pulling 3800 watts, 4600 watts off the battery system. I'll just turn this on again, just get it cranking one more time. Inverter system, loving it. Battery's loving it. The kettle, the toaster just popped. So that's where our loads have disappeared. I'll just turn that back on again. Yeah, that kicks back in. Battery's handling it, inverter handling it. Yes, the internal temperature of the inverter is going to get warm, but you can't do much about that. That's what the inbuilt fans are for. Terminal temperature, we're getting up to 27 degrees now. Still absolutely well within our guidelines. And then down at the circuit breaker, it's 30 degrees. So we're doing perfectly fine here. And then I'm just going to go through and turn everything off. Okay. And our battery voltage is bounced straight back up to 13 volts. Even after that heavy discharge, you'll hear the fans of the two units there. On our batteries, we've got our MOSFET temperature at 42 degrees, which that'll turn off at 80, and then our battery temp 1, 2. So you've got two cell temperature sensors as well. They're at 29 and 28, which is roughly what we're getting off the active terminal. And then down at the circuit breaker for the inverter, we're getting 30 degrees. So it can be done. If you only had the one battery, 100% I would not advise it. If you have the two to share their load of the heat, that is okay. You've got two circuit breakers, you've got two batteries. If you only have one of each, absolutely not. I'd say do a 24 volt system, and that's the only time I would say to do that. I have a very strong belief that these 48 volt systems that are getting marketed at the moment, they're literally just a money grab, because the units that are being used to do the charging are not efficient at all. Now, there is a unit in Australia being built and being designed that's already on the market, or not on the market, but it is already a real thing. That is a pretty efficient 12 volt to 48 volt DC charger, but I don't think that will be released until sometime in 2026, even if it is released then, because the company likes to do a lot of testing before they release things, which is great. I don't believe a 48 volt system for a caravan like this is a viable option. The DC chargers that are on the market at the moment, they're not even DC chargers, they're DC converters, because they're trying to put your inverter and your charger in one unit. And I've had multiple vehicles in the last 2-3 months that have come into the workshop, 48 volt systems, a lot of them from a certain brand from Queensland. I say to them, sorry, I can't do much apart from rip it all out and start from scratch and give you something that's going to work and be reliable. We do these systems every week, and we have customers that give us 10 out of 10 every week and say, yep, it has not missed a beat, it's done everything it's meant to. The only time you're ever going to need to go to 24 volt system is if you need a big inverter like a 5KVA or bigger, and you've only got space for one battery or more. Cable size, look, it's 1/2 meter, it doesn't matter, you're going to be costing about the same, plus with the 24 volt system you need a step down converter anyway. If you're doing a retrofit, a little bit different because you're running all of your cables in the caravan, all the cables already run, so you don't need to worry about that. That's just my 2 cents. I'm not going to get into it too crazy because it just turns into a YouTube war of who's right and who's wrong, and no one's right, no one's wrong. It's it totally depends on your own situation. Like I've always done in all our videos, and I've said it plenty, just keep things simple. Keep things silly simple. If one of these solar controllers goes in there over in the middle of WA somewhere, there's an auto sparky over there that's dealt with Victron that he'll be able to swap that out in 30 seconds. If you've got a 48 volt system with a 100 watt array, there's a good chance that they're not going to do it. And that's why we have had so many people come past our workshop in the last month, 2 months, 3 months with these 48 volt systems, and they've all been from Sydney. And it's because no sparky in Sydney will look at their 48 volt system, come here and go, yeah, that's fine, we can look at it, we can sort it out. And then as soon as I see the products that are inside of it, I go, sorry, with these products, we can't help you apart from swap it all out. So obviously this is the roof with all the solar. As you can see, it's an empty workshop, so I don't have a ladder here. So 2 100 watters at the front, they're off the 20 amp. This side's 150, that side's another 50, so that's 500 watts. 500 watts. This is 2 80 watt panels, and then that same circuit also does the Anderson plug for the blankets. And I've made sure to advise this customer of 2 separate brands that do 300 watt blankets that are the same voltages as what these 2 80 watters are. So you'll be pretty much 100% efficient across the whole vehicle, whole solar array. You got what, 1200 plus 160, so you got 1360 watts total on the roof, plus an actual regulated Anderson plug input. So let's say if you want to have a 300 watt blanket plugged in as well, that's going to get you up to 1600 watts of solar, 1.6 kilowatts. Quick one just of the finished product with all the labels from the label kit on there. Just got a write on this one to say how many amp hours of battery and that it's lithium. If you've got any questions about this system, leave them in the comments. I'll do my best to answer them. And this is one of the last videos that we're going to do for 2025. So thank you to all the people that have, you know, supported our YouTube, and it's going to be a bigger and better 2026. We've moved to a new complex that's about 3 to 4 times the size of where we were here. Our range of services is also expanding, which we'll probably touch on in a later video when I'll do a new sort of workshop walkthrough video. Thank you, and have a safe and Merry Christmas and a good New Year as well.